want to solve this system of two equations with two unknowns using the Gaussian elimination row reduction with back substitution method. So the first thing to do is to write this system of equations as an augmented matrix. Remember, the word augmented means added to. So we're going to take the coefficient matrix, meaning the coefficients of the x's and the coefficients of the y's. So 2 and 5, 3 and -2. And we're going to augment it with the answers on this side, or the constants. So that is the augmented matrix. Now remember, there are three things that we can do, three what are called row operations. The three row operations are: we can swap rows, we can multiply a row by a constant, or the third one, we can multiply a row by a constant and add to another row. So when we do that, I say that we're not really multiplying the row by a constant. We're kind of pretending we are, and then adding it to the row we want it added to. Okay, so our goal is to get ones along this diagonal with zeros underneath, and then we can back substitute. Often we're just happy to have non-zero numbers along the diagonal. It's easier to get the zeros below if we use ones, although the last one doesn't matter as much. So I could leave this pivot position here as a 2, but it's going to be easier if I do it as a 1, and then I won't have to deal with the fractions down here as much. So what I'm going to do is I'm going to take this and multiply this top row by 1/2. So this top row is called row 1. So I'm going to say 1/2 times row 1. That's the notation that I'm going to use. And then what we do is we say they're equivalent, and our little notation for equivalent is a little squiggly. So they're not equal. The matrices aren't equal. They're equivalent that they have the same solution. So multiplying row 1 by 1/2, 2 times 1/2 would be 1. 3 times 1/2 would be 3/2, and 4 times 1/2 would be 2. The second row is not changing. Okay. So now my goal is to get a 0 here. So what I would need to add to get a 0 here would be a -5. So I am going to, the way I word it is, pretend to multiply this top row by a -5, and then add that to the second row. Okay, so I'm going to really, the name of what I'm doing is I'm going to do -5 times row 1 and add it to row 2, putting the answer in row 2. Okay, so if I multiply this top one by -5, I'm going to write this in green, which would be the same as writing it in pencil, so I can erase it. It's not really there. Or if you're good, you can do it in your head. So I'm multiplying this top row by -5. So this is going to be -15/2. -5 times 3 is -15. -5 times 2 is -10. And then I'm going to add those numbers to the second row. So this is going to be equivalent to, first row, remember I said was not really changing. So I'm going to leave that first row the same. Okay, so negative 5 plus 5 is 0. Negative 15 halves minus 2, that's 10 halves. So negative 15 halves plus a negative 10 halves is a negative 25 halves. And negative 10 plus 6 is negative 4. So this is echelon form, row reduced. We want to reduce it all the way. We would get this to a 1 and that to a 0. But at this point, we can stop and do what's called back substitution. Because what's this equation going to be equivalent to? This equation is going to be equivalent to these numbers on the left being coefficients of x, these being coefficients of y, and this being the answer. So this is going to be like 1x plus 3 halves y equals 2. This was going to be 0x. I'm not even going to write the x. Negative 25 halves y equals negative 4. So notice this is not the same system we originally had, but it's equivalent in the sense that the two systems have the same solution point, the same xy point. I can easily solve this one now for the y. All I have to do is multiply both sides by the reciprocal. We'll multiply both sides by 2 over negative 25. That becomes 1 over 1. So y equals negative 8 or negative 25 or 8/25. So I now know the y value. I can plug it back into this original one. So I'm going to take this 8/25 and put it in for this y value. So I have x plus, because 1 times x is just x. So I have x plus 3 halves times 8/25 equals 2. So I can easily solve for the x. X plus 3 times 8 is 24. 2 times 25 is 50. I can reduce that 24/50 to 12 over 25. I could have done it along the way. I could have done the 2 into the 8 and made it 4. Okay, so now x is going to equal 2 minus 12/25. Well, to get the common denominator, I got to multiply by 25 over 25. So 50/25 minus 12/25 is going to give me 50 minus 12 over 25. So I have 38/25. So my solution is 8/25. Whoops. Be careful. X has to come first. The x is the 38/25, and the y is the 8/25. So that's my xy solution, 38/25, comma 8/25. Okay, let's try one that has 3 equations and 3 unknowns. The first step again is to write the augmented matrix. So the coefficients of the x's are 2, 1, and 3. Coefficients of the y are negative 3, 2, and 1. Coefficients of the z are 1, negative 3, and 4. The augmented part, or these call them answers, are 2, 0, and negative 2. Again, it's nice to have a 1 up in the top. So I am going to swap the rows, row 1 and row 2. I'm going to swap, put an arrow on each end showing that they are swapping. So row 1 is now going to be 1, 2, negative 3, 0, and row 2 is going to be 2, negative 3, 1, 2. So the whole second row is what the first row used to be. The whole first row is what the second row used to be. The third row is not changing. This is equivalent to this one, equivalent in the sense that it has the same solution. Okay, now I would like to get zeros under here. So what I'm going to do is multiply this top row by negative 2, negative 2, negative 4, by negative 2 would be a positive 6, and that would be a 0, and I'm going to add those numbers to the second row. So what I'm doing is negative 2 times row 1 plus row 2, and I'm putting the answer into row 2. So negative 2 times the first row plus the second row into row 2. Notice the first row isn't really changing. So that's why I wrote it up there above it in pencil, or green in my case, so you can see it. Negative 2 and 2 is 0. Negative 4, negative 3 is negative 7. 6 and 1 is 7. 0 and 2 is 2. Get good at that. You can do the second and third row at the same time, but I am going to separate it into 2 steps. Now I'd like a negative 3 to get added to that one. So I'm going to do negative 3 times row 1 plus row 3, and I'm going to put my answer into row 3. So I'm going to multiply the top row by negative 3. Not really, so I'm penciling it in. Negative 3 times 1, negative 3 times 2, negative 3 times negative 3, and negative 3 times 0. And then I'm going to take that and add it to my third row. So again, the first row is not really changing. Second row is not really changing. Already changed it. The third row is changing. Negative 6 and 1 is negative 5, 9 and 4, 13, 0, and negative 2. So I've completed the idea of getting 1 with the zeros underneath. Now I can leave that negative 7 and use that as my pivot, but I think it's usually easier if you go ahead as if you were going to go all the way to the row reducing and put a 1 there. So I am going to multiply negative 1/7 by row 2. I'm going to put it into row 2. So I'm literally just going to multiply that second row by negative 1/7. So the first row stays the same. I multiply by negative 1/7, I get a 1. 7 times negative 1/7 is negative 1. And 2 times negative 1/7 is negative 2/7. I have not done the second row, the third row yet, but I'm going to do that next. So notice it's going to be easier to determine what to multiply this by to add to this to get 0 with a 1 there than it is with a negative 7. That's why I went ahead and multiplied by that negative 7. Okay, so now what I'm going to do is I would like there to be a 5 to get added to this to get a 0. So I need a 5 times row 2 plus row 3, and that's going into row 3. Again, I'm not really going to multiply my second row by 5. I'm just going to pretend I do. So I'm going to pencil it in. Multiplying by 5 multiplying by 5, multiplying by 5, multiplying by 5 is negative 10 sevenths. And like I said, if you're good enough at arithmetic, you can use your calculator. You can use your head or your calculator. Right? So this line is not really changing. It's really going to stay 0, 1, negative 2 sevenths. But I'm going to now add that to the third row. 5 and negative 5. Negative 5 and 13 is 8. Negative 10 sevenths minus 2. So that's negative 14 sevenths. So negative 10 sevenths and negative 14 sevenths is negative 24 sevenths. Now I can go back and write my equivalent system of equations using the coefficients. So that top one's going to be 1x, or just x, plus 2y minus 3z equals 0. The second one's going to be y minus z equals negative 2 sevenths. And the last one's going to be 8z equals negative 24 sevenths. So the idea is now I can use these in order to solve for z, take that answer, plug it into the one above it, then take that answer and plug it into the one above it. So let's start first to find z. All we have to do to find z is multiply both sides by 1/8, the reciprocal, which of course is the same as dividing by 8. Remember, you divide by fractions by multiplying their reciprocals. So dividing by 8 or multiplying by 1/8, that'll be 1z. 8 goes into 24 3 times. So negative 3 sevenths is my z. I'm going to take that value and I'm going to plug it in here for my z. So y minus a negative 3 sevenths equals a negative 2 sevenths. Of course, when you subtract a negative, that's the same as doing addition. So I really have y plus 3 sevenths equals negative 2 sevenths. I'm going to subtract negative 3 sevenths from both sides. So when I do that, I'm going to get y equals negative 5 sevenths. So I've now solved for y. So I'm going to take this y and this z value and plug it back into this original one. So I'm going to have x plus 2y, that's 2 times negative 5 sevenths, minus 3 times z, which is negative 3 sevenths, equals 0. So I'm going to work all of this out. Positive times a negative is a negative 10 sevenths. Negative and a negative is a positive 9 sevenths. Those already have like terms, how convenient. So x minus 1/7 is 0, add to both sides, so x is 1/7. So now I have my x, y, z point, which is 1/7 is the x, the y is negative 5 sevenths, and the z is negative 3 sevenths. That is the point of intersection of those three lines.